Hello and welcome to a new video. So in this video we are going to solve the following equation. 4/3 times 1 over x minus the integer part of 1 over x is equal to x. So this is yet another equation involving the integer part. Okay, so before we get to the solution, a reminder as usual. So for any real number x, the integer part of x is an integer p such that x belongs to this interval. In other words, the integer part of x is the greatest integer such that it is less than or equal to x. So, and for any real number x, x can always be written as the sum of two components. The first component is the integer part, and the second component is the fractional part. And the fractional part belongs always to the semi-open interval 0, 1. Okay, so to the equation now. So if we start now with this equation, we notice that the term between the parentheses is nothing but the fractional part of 1 over x. So if we look at this one, so x minus its integer part is always equal to its fractional part, and the same applies here. 1 over x minus its integer part is equal to its fractional part. So we get this equation, and since we know that the fractional part always belongs to the semi-open interval 0, 1, then the left hand side here always belongs to the open interval 0, 4/3. And since we have an equation, then x belongs to the same interval. And you may wonder why you don't have open interval, a closed interval at 0. This is because if x equal to 0, the equation is not defined. So we have an open interval. Okay, so if x now belongs to the open interval 0, 4/3, then 1 over x being different from 0, belongs to the open interval 3/4 up to infinity. And since all natural numbers lies here, then the integer part of 1 over x belongs to n, the set of all natural numbers. All right. So now we know that the integer part of 1 over x can take any natural number. So by setting the integer part 1 over x equal to p, we can now solve the equation. So by letting the integer part of 1 over x equal to p, the equation becomes like this. And then simplifying or rewriting, so we get an equation of the second degree, which we can solve, and we get the solutions like this. X is equal to 1/3 times minus 2p plus 2 square root of p squared plus 3. And since p is an arbitrary natural number, then we have an infinite number of solutions. These are the solutions. So finally, this set, where p belongs to n, is the set of infinite solutions to the equation from the beginning here. So for example, if p is 0, so letting p equal to 0 here, then we get x0 is equal to 2 divided by the square root of 3, this is one solution. And if, for example, p is equal to 1, x1 would be equal to 2/3. Alright, thanks for watching, and see you in the next video.